Welcome, ladies and gentlemen. My name is Brian McLogan, and in this video, we are going to work on what you need to know for analytic geometry, also known as conic sections, which is our next chapter in the precalculus unit. So what I did was I just kind of chose some problems that I feel that by completing these, students are going to be well prepared to be able to go through the problems that they are going to be confronted with in this chapter. So what I chose was completing the square problems, finding like the vertex of a parabola by completing the square. Also have ones where we have terms that we need to factor out, divide those out. We're going to work on how to identify the midpoint as well as how to identify the endpoint when we're given a one endpoint and a midpoint. Some good old geometry questions. We're going to practice writing the equation of a circle and given to some different pieces of information. And then we'll just go back to solving some equations, solving for x when we have a rational equation. Nothing crazy, but just some problems, just to kind of go through the practice of what we can do. So again, this is not everything you need to know. And again, just by completing this, it doesn't mean you're going to be fully prepared, but I really do believe that by having this, you'll feel more comfortable and confident working into the lesson. So one of the big points is the completing the square. And we've already kind of covered completing the square in my class, but now in this chapter, some of those more difficult problems arise. So students don't have a decent foundation for completing the square. It starts to become overwhelming. So remember, when we have, basically there's two forms that we have worked on in this class for quadratics, ax squared plus bx plus c, which is called our standard form. And then we have the vertex form. Y equals a times x minus h squared plus k. All right, so here's the forms that we are provided, and we want to basically go from standard to vertex form. And the idea here is what we did in like our lesson 2 in chapter 2, was we want to create a binomial squared. Now there is only one type of polynomial that creates that binomial squared, and that is called a perfect square trinomial. And you can see in this case, the first two examples I actually chose perfect square trinomials. Like if you were to factor these, I'd say what two numbers multiply to give you 1, add to give you 2, right? So we know the product here. What two numbers multiply to give you 1, add to give you 2? And you can say, oh, that's going to be x plus 1 times x plus 1. And therefore that gives you x plus 1 squared. So I just went from standard form to vertex form just by factoring. So you can see how we like that. Like, that allowed us to write this as a binomial squared. Now, in terms of the vertex, we need to have like whatever k is. Well, since there's nothing there, we can say 0. So therefore, our vertex is going to be -1, 0. Remember, it's x minus h to the vertex. So the vertex is, remember, h, k. All right, so this next one, again, we can say, first thing we always want to look at is a perfect square trinomial, right? So this first one, we can say, all right, well, what number do I need to what two numbers multiply to give you 9, add to give you -6? Well, the only two numbers that I know multiply to give you 9, add to give you -6 is a -3 and a -3. So I could spend my time factoring this out like this, but in reality, once you recognize that it's a perfect square trinomial, you can just write it as x minus 3 squared. So now the vertex in this case is going to be 3, 0. So you can see, all right, rather easy, right? So what happens then if it's not a perfect square trinomial? So for instance, this is not a perfect square trinomial. We do not have a third term. So basically what we do, kind of like this question, a lot of times we'll give it like a C, and we'll say, well, what number could I add to this equation that would make it a perfect square trinomial? So a lot of times we'll say, what number, x squared minus 4x plus c, what number could I add that would create this to be a perfect square trinomial? And there's an easy way to do this. C is going to be b divided by 2 squared. So if you look at that, if I wanted to create my perfect square trinomial, all I'm going to do is take my middle term, which is my linear coefficient, so that's -4, divide it by 2, and square it. So -4 divided by 2 is -2. -2 squared is 4. Now let's go and see if this works. So if I take y equals x squared minus 4x plus 4, you can see now I just created a perfect square trinomial, right? Beautiful. So I'm going to put these in parentheses because that is my perfect square trinomial, because what two numbers multiply to give you 4, add to give you -4? That's -2 and -2. However, beware, you just can't randomly add some number to an equation and say it's all good. If you're going to add 4, then you also have to make sure that you subtract 4, right? Because if I have an equation, like if I say, for instance, like x equals 1, I can't say x equals 1 minus 2. I would have to add 2. And again, like that still works, right? That still is an equation, but you just can't randomly add a number and not actually keep the equation to be the same. So therefore, what I'm going to do is I'm just adding that 4 to group it. That's going to be my perfect square trinomial that I know I can factor to x minus 2 squared, and then I'll have the minus 4 on the outside, okay? So in this case, we're kind of going to do the same thing. What we're going to do is I'm going to group the first two terms because 8, there are no two numbers that multiply to give me 8 that add to give me positive 8. That is going to create this perfect square trinomial. So what I'm going to do is I need to create a perfect square trinomial inside of these parentheses. So I'm just going to kind of forget about this outside 8 for a second. And then you could do the 8 divided by 2 squared. So y equals, let's do this. So I'm going to take an 8, the middle term, divided by 2 and square it. So 8 divided by 2 is 4. 4 squared is 16. So I have y equals x squared plus 8x. I need to add this in there, right? Because now that creates my perfect square trinomial. But again, you just can't add a 16. You have to subtract a 16. And then I'll put the 8 right there. All right, but again, this whole goal of taking this b divided by 2 is to create that perfect square trinomial. So now I can factor that. So what two numbers multiply to give me 16, add to give me 8? You can see, oh, that's going to be y plus 4. Oops, not y. X plus 4 squared. And then negative 8 plus 8 is going to be a negative 8. Or negative 16, sorry, plus 8 is a negative 8. All right. So the next two examples is where it starts to get really fun. Because we can only, my description of completing the square only works when you have x squared, meaning there is no coefficient of x squared. So in these problems, I have a coefficient of x squared. And so what I need to do is first factor that out. Now again, my only goal here is creating a perfect square out of these first two terms. I can deal with this negative 21 at the very, very end. So first thing I'm going to do is I need to factor out the negative. Now I have an x squared minus 12x minus 21. Now what I can do is I can take now I can complete the square here. I have x squared minus 12x. It's kind of like this problem again. It's basically saying, how do I create this perfect square trinomial, right? How do I find this value c? I take the negative 12 divided by 2, which is negative 6, and then I square that. So negative 12 divided by 2 is negative 6. Negative 6 squared is going to give me a positive 36. Now, this is where it gets really confusing for most students. So I'm going to add the 36 in there, right? Now, I also need to make sure I subtract the 36, right? That was used to it. But again, you got to understand, when you put a 36 inside parentheses, that 36 is actually also being multiplied by a negative. So you're really actually not adding a 36, you're actually subtracting a 36, right? Because via distributive property, this 36 is being multiplied by a negative 1. So when you subtract a 36, you also need to multiply this by a negative 1, and then we'll put the negative 21 at the very, very end. Now, to go through all this, again, we created this perfect square trinomial, so we just need to factor this. That's going to be, oh, I forgot to write the vertex. I'll go back to that at the end. So this becomes a negative 6 squared, and then this becomes a positive 36, and therefore minus 21, so that's going to be a positive 15. All right, let's go back and write the vertex here. So the vertex here is going to be 2, negative 4. The vertex here is going to be negative 4, negative 8. The vertex here is going to be positive 6, 15. All right, so let's do the next one. Again, we're only concerned here about grouping, creating a perfect square trinomial with these first two terms. So I'm going to factor out a 2. That gives me x squared plus 10x plus 27. Now again, I need to create this as a perfect square trinomial. So I'm going to take 10 divided by 2 and square it. 10 divided by 2 is 5. 5 squared is 25. So therefore, I'm going to take that number, 2 times x squared plus 10x, add 25. I don't know why that weird thing. So I'm going to add the 25, put that inside those parentheses. But again, remember, you just can't randomly add 25. If you're going to add 25, you have to subtract 25, right? But again, that 25 is actually being multiplied by 2. Via distributive property, everything inside this parentheses is being multiplied by 2. So if you add a 25 here being multiplied by 2, you have to subtract a 25 being multiplied by 2. And then we'll just add an extra, then we just take the 27 and we add that there. Now, I know this is a perfect square trinomial because every single time I do this, I'm creating a perfect square trinomial. So I say, all right, what binomial squared is this going to produce? How about x plus 5 squared? And then this becomes a, let's see, negative 25 times 2 is going to be a negative 50. And therefore, this would be a negative 23. So now my vertex is going to be a negative 5, negative 23. So hopefully that process, you'll see we're going to be doing a lot of completing the square in this section. So hopefully this kind of builds up that practice of creating those binomial squareds. All right, so for the next problem, we need to find the midpoint as well as find how to find the end point. So basically what we do is we have 2 points. And I think the best thing to do here is just to plot the points on a graph so we can have a visual. And I get very frustrated a lot of times in this chapter when students, have trouble doing a problem, but they will give up before they actually try to sketch the graph. So in this case, we have 1, 2, let's call this A. And then we have another point C, which is 1, 2, 3, 4, 5, and 2. And we're going to call that point C. Okay, so in the first example is just to find the midpoint of B, A to C. Now, I think with this problem is you can kind of see you could find the midpoint. I'll go through the midpoint formula here. But in reality, when we see this, we're just going to count here. Let's just draw a line here. Here's the line AC. Well, this is 1, 2, 3, 4, right? So if I go 2 to the right and 2 to the left, you can see that is my midpoint B, right? So I can just say here the midpoint looks like it's going to be at 1, 2, 3, 2. So let's just say the point B is going to be 3, 2. Now, again, this is very easy because the problem that I chose was rather simple, and that was on purpose, so you could see how this visually works. I understand there's going to be problems that it's not going to work out as nice. So we need to make sure we have the formula that we can kind of follow when we have problems that maybe is not as easy to graph. Like if we have radicals and we're not going to be able to do that or something crazy. So again, we have coordinate points. Each coordinate point is an x and a y. But since we have more x and more than one y, we're going to want to differentiate them using subscripts. So we're going to call this x1, y1, and x2, y2. So if I want to find the midpoint, B, all I'm simply going to do is you're basically going to find the middle distance of the horizontal as well as the vertical distance. So, yeah. Oh, yeah, that's right. So what we're going to do for this, or let me just write the midpoint here. So find the midpoint. So we're going to have x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. So that's the midpoint formula. And again, if you look at it, if you add 1 plus 5 is 6, 6 divided by 2 is 3. 2 plus 2 is 4, divided by 2 is 2. So you can see how we could get those points using the formula. However, I think if you can visually represent it, that's going to be the easiest way to kind of work on that, start on that problem. The next one is find the endpoint D given AD as a midpoint C. So now it's saying, let's go ahead and find D over here, given that C is the midpoint. Well, again, if you understand the distance from A to C is 1, 2, 3, 4, and C is the midpoint, obviously following along the same line, then I could really just add another 4, so how far am I over? 1, 2, so 1, 2, what am I at? 5, 2. So if I just add 4, I'm going to be at, so my D is just going to be at 9, 2. Right? Because really from here to here is going to equal to that, then you just add another 4 more in there. However, let's kind of go through this midpoint form here, or kind of look at what we can do algebraically, right? Because we know that C is the midpoint of our line AD. So again, we're going to look at this horizontal as well as the vertical distance. So if we remember that the midpoint formula, x1 plus x2 divided by 2 equals like that first coordinate of the midpoint, right? Well, remember the midpoint here, they're saying C is the midpoint. So that's going to equal 5. So what we can do is actually say, so that's going to equal the first coordinate of the midpoint, which in this case is going to be 5. Now, x1 in this case is going to be A. So what I'm going to do is I'm just going to replace x1 here with 1. Now, what we want to do is find this second point, x2, right? And actually, you know what? I'm going to, we'll call this x2. And let's actually do this as, let's do this as x3, okay? Because our point D or C, no, my point D here, I'm going to use as x3 is going to be x3 and y3. All right, so we know that A plus this x3 point, part of C, divided by 2 is equal to that midpoint, which we know as going to be C, which is 5. So now we just solve for x3. So again, to get 2 off the denominator, you're going to multiply by 2 on both sides. And therefore, you get 1 plus x third equals 10. Subtract 1, subtract 1. x3 is 9, which we already kind of knew. And then again, we can do this for the y-coordinate as well, right? So we have the y-coordinate here is 2 plus y3 over 2 is going to equal to the y-coordinate here, which is 2. So again, multiply by 2 on both sides. And you have 2 plus y3 equals 4. Subtract 2, subtract 2. y3 is equal to 2. And then we just write that as a coordinate point, 9, 2, which is your D coordinate. So you can see the difference. Obviously, the midpoint is just very easy. Just using the formula or looking at that visual. And then it gets a little bit tricky algebraically when you're given an endpoint and a midpoint. But again, just use that formula to help you and the information. You can go ahead and solve it just exactly the same. All right, so what about the equation of a circle? So remember, there's 2 equations of a circle. When we have the center of the circle is at the origin, then we have x squared plus y squared equals r squared. When we have the origin is at hk, then we are going to have our formula is going to be x minus h squared plus y minus k squared equals r squared. So again, remember r equals the radius of the circle. Okay, so in this case, we have our origin, which we know is going to be at 0, 0, and we have a radius 4. So all we're simply going to do is have x squared plus y squared equals 4 squared. So the equation of the circle, x squared plus y squared equals 16. Can't be any easier than that. The next one is we have the endpoints of the diameter. So let's go ahead and plot this here real quick. So we have -1, 5. Okay, and we have -1, -1. Okay, so easily what we could do here is we could use the distance formula, right? But I think you guys could agree that since we've graphed this, we can see that this distance, the diameter, is equal to 6. So if the diameter is equal to 6, that means the radius is going to equal to 3. Now, the other important thing that we can do, or the other important thing we need to figure out is where is the center of the circle? Well, remember, the center is going to be the midpoint of the diameter. So we could use the distance form or the midpoint formula, right? But again, since I plotted this, right, here is B, here's A, I can just see this midpoint here is going to be 1, 2, 3, 1, 2, 3. So I can say there is going to be my center. So I'll just say C, which is going to be -1, 2, is going to represent my center. Okay, so now I have my h, my k, and I know the radius is 3. So I can just write x, it's minus -1 squared plus y minus 2 quantity squared equals 3 squared. And as I just simplify, x minus the -1 is going to be x plus 1 plus y minus 2 quantity squared equals 9. On the next one, we have center is 3, -2, and radius is 5. So again, this one is actually a little bit easier than the last one. We have our hk and we have our r. So basically, we're just going to use the x minus h squared plus y minus k squared equals r squared. And again, just plug in your values here. So we have x minus 3 squared plus y minus a -2 squared equals 5 squared. And then you could just simplify this. I'm showing my work because I'm a teacher, but obviously you could go through this, skip that second step and just go right to there. All right, last example. We have the center negative 2, 4, and then the graph is tangent to the y-axis. So again, I think it's really important just to plot this information here. So we have a negative 2, 4, 1, 2, 3, 4. And then it's saying it's tangent to the y-axis. So again, remember tangent means that it's only going to touch at that one point here, right there. Well, the nice thing about that, since it only touches one point, we can see that the distance from there to there is 2. So we can say that we have our center, HK, and now from graphing that, we can see the radius is going to be 2. So I'm just going to go and write the equation now. We have x plus 2 squared plus y minus 4, quantity squared, equals 2 squared, which is 4. All right, lastly now, we're just going to practice solving for x and for rational equations, something that we kind of already did. But we're just going to kind of work through, some different operations. Now, in this case, we only have like one variable x. It's not like some crazy polynomials like we did for the other rational equations. So for this one, we can just use inverse operations. Like if I just add 3 over 4, right? I can do this x over 2 equals, I can rewrite 1 as 4 over 4 plus 3 over 4. So x over 2 equals 7/4. And then if I want to solve for x, I'm just going to multiply by 2 on both sides. So x equals, you could do 2 times 7 is 14, divided by 2, and then just reduce that. Or you can just simplify that out, and you can see you get 7/2. Okay? 2 over 4 reduces to 1/2, so it's 7 times 1/2, which is 7/2. In the next case, again, you could just, now, yeah. So you could do the inverse operate. Do I have more room for this? Yeah, I do. So another way you could look at the problem is just multiply by the LCD. And again, the LCD in this case is going to be, this is my preferred method. The LCD in this case is going to be 4. So if you just multiply everything by 4, right? So the LCD is equal to 4, right? So if I just multiply everything by 4, I get 2x minus 3 equals 1. Uh-oh, what happened here? Why am I not getting the same answer? That's 3/4 plus 3/4. Oh, that's a 7/4, yes. Times 2, 7/2. What happened here? So that's a 2x. Oh, that becomes 4. Sorry. I was wondering, I'm like, what the heck happened here? So if I add 3, then I have 2x is equal to 7. Divide by 2, x equals 7/2. Okay, so I kind of prefer that method as well. So why don't we just do that one? Because you could subtract to 5/4, right? But most students don't want to subtract and to get to 5/4, then you got to do the x. So my goal here is why don't we just multiply by the LCD? So the LCD in this case is going to be 4x. So I'm just going to multiply everything times 4x. Everything times 4x. So I have 3 over x plus 5/4 times 4x equals 1 times 4x. So now you can see the x's are going to divide out. That's just going to give me 12. Here the 4's are going to divide out. So that's going to give me, so that's going to be plus a 5x. And then here you just have 1 times 4x equals 4x. So now I can just go ahead and subtract the 5x to both sides. I get 12 equals a negative x. Divide by negative 1, divide by negative 1, x equals a negative 12. Okay, so again, just different ways to, so you can always use fraction operations or look into identifying the LCD and just multiplying everything by there. The main thing is you're going to have to multiply by x eventually in this problem because you can't solve for x in the denominator. The next example here is, now I could do LCD in this case, but let's do the fraction operations. Let's just subtract 5/9. So again, we could rewrite 1 I could rewrite 1 as, 9 over 9. So I have x minus 1, quantity squared over 4, equals 9 over 9 minus 5/9. Well, that's going to give me a 4/9. So x minus 1, quantity squared over 4, equals 4/9. Now, to get the 4 off the denominator, I can multiply by 4 on both sides. I'm going to get x minus 1, quantity squared, that goes to 1, is going to equal 16 over 9 square root both sides to get rid of the squared. And I get x minus 1 equals plus or minus the square root of, remember that can be broken down into, I can break that down into the square root of 16 over 9, which is going to be 4/3. And then I'll just have x. And then we're going to add a 1. So x equals 1 plus or minus 4/3. And we'll just leave it from there. Again, this is really just kind of working into those operations so you can kind of see how it works. And obviously, once we get into more problems, you'll kind of see how these relate to them and to be able to solve for those certain problems. So hopefully this helps you out with your with some of those operations. Just kind of remember, solving rational equations when x is in the numerator compared to x is within the denominator compared to when it's within a inside of a quantity squared. Making sure you know how to write the equation of a circle. Again, doing some more coordinate geometry and then completing the square are some of those big processes. So hopefully this helps, and I look forward to seeing you in these videos. Cheers.